Picking up where we left off, I'm going to build my towers next. Activate the entire assembly. I'll open a sketch. Nope. Add a new component. This is going to be my tower. I'll open a sketch on this face. And I'm going to set it back a little bit. I'll dimension this in a second. First, I'll dimension the distance from here to here. I'll put that at 1 inch. Now I need to dimension the tower itself. So we have 1.5 inches here and another 1.5 inches here, which means that this is constrained to be a maximum of 15 inches tall. This dimension is going to be 1.5. And then we're going to extrude it. We can change the extent type to object, and we can click this face here. And that's going to make it match. And that would be 1 5/8. Add a material here, boom. Go back to our home view. Now let's just verify that this is within spec. Click this bottom face, rotate around, click this top face. We have 18 inches. Perfect. Let's copy and paste, activate the assembly, click the tower in our browser, Control-C, Control-V, move this. Five 5/8. That's what we want right there. Now we might find that we actually want to back this up a little bit more this way in the name of creating larger supports. And I'm actually going to do that. I can tell by looking at this right now that I want to do that. So I'll reopen this sketch. And instead of right there, I'm going to say 2 inch. That looks good to me. Let's create some tower supports. Activate the assembly, new component. I'm going to call this small brace. This is going to be relatively simple. All we're going to do is open a sketch on this face, draw a line from here to, we got to project this geometry. P is our shortcut. Click here, select OK. Draw a line from this corner to right there. D for our dimension tool, click this line, 45 degrees. That's what we want, boom. Draw another line from here to here, and here to here. There's our shape. Extrude, orbit around, to object, click that face, select OK right here. Boom. There we go. physical material, pull pine over. There we go. Honestly, looks kind of dinky. I'm not really sure how much it'll help. So I'm going to go back and I'm going to move this back even further to allow more space. Let's put this to 3 inches. Now you'll see I parametrically modeled the small base so that its geometry automatically updates based on the position of the tower. And I can activate the entire assembly. Click the small brace, Control C, Control V. Move this over. That's going to be 5 5/8 again, I believe. Perfect, right there. Looking good. I do always need to be thinking about whether or not I'm going to be able to manufacture what I am designing. We've talked about design for manufacturing. How long is this edge? Three inches. Now, let's think about this. I'm actually not going to be able to get out of a 2x4 a piece that measures a triangular section that measures 3x3 to a depth of 1.625 inches. So I just need to change the depth of this extrusion. Right here, instead of 2 object, this is going to be limited to a distance. This is going to be limited to 1.5 inches. In this case, it needs to be -1.5. Select OK. That little imperfection might bother me a little bit, but I've begun to embrace the wabi-sabi. All right. What else do we need? We need some other supports along the back here. Very similar process. Activate the entire assembly, add a new component, large brace. Project geometry. If you can't, let's see. Open a sketch on this face. Draw a line. Nope, project. Boom, boom. Draw a line between the two. All right, once again, 45-degree angle. Close the shape off. Let's go like 8 inches to start. Now I'm also just realizing, again, I need to be thinking about whether or not I'm going to be able to manufacture this component. I'm limited to 1.5 inches thickness with my 2x4. So what I'm going to do here, I'm going to draw another line parallel. See how my constraint pops up? That's what we want. I can just click and I can add the constraint after as well. Click, click, there we go. Dimension the distance between these two, It's gonna be 1.5 inches. I can trim this shape now as well. And I can trim here too. It's a good start. We can extrude this. Because my 1.5 inch thickness is in this direction, I can go all the way to here with this piece. And I want to right click and add my material. And once again, activate my assembly, Control Z, Control V. Well, activate my assembly, click on the component, Control C, Control V, move it 5.625. Okay, we're looking good. We're getting there. I'm going to stick a piece between the uprights too, to keep these supported and braced and properly spaced. So let's add another component. I'm just going to call this the tower brace. Open a sketch right here. That'll work. I'm going to have to adjust the position of this. .5 in this direction, 4 inches in that direction. I can extrude this to a depth of 1.5. Right click, physical material. Okay, there's my tower brace. That block is just going to add some more stability here. Okay, we're looking good. The only other thing that I need to add, I want to put a cross piece here so that I can precisely control my launch angle. Remember, we're trying to optimize the distance. If you've learned about projectile motion in physics, to optimize the range of a projectile, there is a specific angle that we want to launch at with respect to the horizontal. So I'm going to try to design mine so that I can get that angle. So what I'm going to do here is I want to move it. Let's see. Let's see if I can move this component. No. How am I going to control this? Right click. See if I can edit the joint. Angle, 45 degrees. Right click, edit the joint, angle, negative 45 degrees. Boom, right there. Okay, so now I know this is the exact position at which I want to place a brace between these two posts. Or put my, I'm going to call this a crossbar. So, looking here. Assembly activated, new component, crossbar, crossbar, not crossbarred. Open a new sketch. I'll select this face. Project. This is where our project tool is really going to come in handy. Orbit around, project this face as well. Select OK. Let's look at our front view. Here we go. Okay. Draw a line from here to here. Make sure it's at a right angle. There we go. 1.5 inches. And we know that we can go. Now I'll close this off, right? From here to here. Here to here. And here to here. Now we know that we can go. We want to make this a distance that is easy for us to manufacture. So I'm just going to make this 1 inch. One inch by 1.5. And then we're going to extrude this face to meet the other side. Extend type to object, orbit around, click this face. Perfect. That's exactly what we want. There's our crossbar. Right click, physical material. Boom. Now I know that my launch angle is going to be exactly what I want. I can go back to my Revolute here. I can edit my joint and I can set this back to 0. Ooh. Notice our crossbar moved with it. We don't want that. Let's see. Maybe I should use an as-built joint to put this into place. So Shift J, put this into place, select one. I'll select this large brace right here. Hit OK. Now I'll move this back. See if that works. It's all right, actually. I think what we'll do now is we'll just create our motion limit. Minimum 0, maximum, minimum -45, maximum 0. Animate joint relationships. Okay, not quite. Hit escape. edit, joint, motion, flip. I think that'll work. Try it again. Nope. A little bit of trial and error here. Edit joint. Minimum 0, maximum 45. There she is. That's what we want. Now, I'm not going to ask that you model the hooks and the rubber bands that you'll use to create the tension that launches your projectile, but we should put some kind of a cup on here or something. Actually, you can leave that out because that's a standardized piece that I'll provide to you as well. Let's go ahead and let's attach everything together now. We already have a few to activate our entire assembly. We already have a few joints, and we can just use our as-built joint for a bunch of these. There we go. I am going to move this one. I think it's just 1/8 of an inch. There we go. Shift J, as built here and here. Perfect. Shift J, attach the tower to here. Shift J again, attach the large brace to here. Orbit around, do those same two over here. Shift J. The beauty of modeling the components in the exact position in which they'll be assembled is that you can just use these as-built joints, and it takes 2 seconds. On the back side here, I'll put Shift J here to here. And I think I'm pretty much good to go. I'm going to be wrapping my rubber bands around here and here on the posts. Oh, I do need to attach. Let's see. I do need to put this into place as well. This is my tower brace. Let's see what this distance was from here to here. Kind of arbitrary. Let's make it 3.5 inches so that it's easy to do. And then we can use Shift J once again. Boom. For some reason, this does not look centered now that I'm looking at it. And it is not. What happened there? Let's see. Distance from here to here. Distance from here to here. 6.125. Did some of my math wrong. So let's find Is that it right there? Let's see. 5 3/8. 5 3/8, boom, centered perfectly. Now, what I'm going to ask you guys to submit for this first part, right click, animate joint relationships. I want you to show me the operation of your lever arm with the appropriate motion limits. So you can take a short GIF demonstrating this. In the next video, we'll start to talk about nesting so that you can plan out how you're going to make all the cuts and ensure that you can get all the cuts that you've designed out of the 8-foot 2x4 that you have. And then we'll also begin to create drawings.